Hi everyone, so in today's video we're going to talk a little bit about the functions for the Arduino pins for the Mega 2560, but this should apply to almost any other Arduino board since the pins are clearly labeled on PCB and they pretty much mean the same thing. You know, the digital pins are digital pins and communication means communication and stuff like that. So what we're going to do today is go through different buses, their functions, and how to use them. So let's get started. So a fun fact before we jump into the functionalities, the Mega 2560 is basically an extended version of the Arduino Uno. If we take the right side of the Mega and shrink it to where the holes are in the middle, it becomes an Uno. So the shield for Uno will work on Mega. As you can see here, I have a servo motor shield, and if we plug that into the Mega board,
12 seconds later,
it fits perfectly. So the holes in the middle actually align with the holes in the shield. So the Mega board just get a whole bunch of digital pins on the right hand side of the board and some communication pins on top and some analog pins on the bottom. So let's talk about the pins. Start from 0, you can see here is labeled as TX and RX. They are the receiving and transmitting pins for UART communication. And UART communication stands for Universal Asynchronous Receiver and Transmitter. Now I'm not going to talk too much about the UART communication in this video, but you can think them as kind of the USB port for the Arduino, but in the forms of Arduino pins. Actually, you can replace the USB port with those pins. And if you want to have two Arduinos talk to each other, or maybe you want to send a signal from a Raspberry Pi to an Arduino, you can totally use those pins. And there are some more transmitter and receiver pins labeled as TX1, RX1, and so on. And you can connect some communication modules like Bluetooth or Wi-Fi to control your Arduino through those pins. So let's just finish the communication pins. Pin 20 and 21 are pins for I2C communication, which is what you want to use when you have a master device and multiple slaves. And you only need those two wires to connect all of them. Now the SDA is the data line and SCL is clock signal. I'll talk about how to use them later in some other videos. Now let's move on to pin 2 through pin 13. As you can see here, they are labeled as PWM pins, and PWM stands for pulse width modulation. You can use those pins to send signal to several motors to control the position, send signals to light to control the brightness, or to DC motors to control the speed, and so on. And they can also be used as digital pins, which we'll talk about next. Okay, on the right hand side, almost all of them are digital pins except 2 on the top and 2 on the bottom, which are the 5V and the ground. And you can use the digital pins to read or write digital signals. Differences between the PWM pins and the digital pins is that PWM can set to have a frequency of on and off signals, so sort of like flickering lights. But for digital pins, you can only set them to either constant high or constant low, and that's a light without flicker. They can be used to turn on and off an LED, send signal to enable pins in other circuits. So move on to the bottom. The A0 and A15 are the analog pins. They're typically used for reading signals from potentiometers where the signal is continuous instead of either on and off signal are used for digital pins. So the power pins are pretty straightforward. The 3.3 and 5 volts are the voltage supplied to other devices. You can plug devices that are not very power hungry to the Arduino and drive them from there. And ground pins are at the same voltage level as all other ground pins across the board, and you can sort of see them as the negative terminal. And VIN means that you can supply power to the Arduino. It serves the same functionality as the black connector on the left. Now let's talk about the pins that are not used very often. The AREF or AREF pin stands for analog reference, which takes an external voltage as a reference for analog reads. It will change the definition for the maximum analog input when that pin is connected to an external power source. Now let's say if you are measuring a distance with a certain device, and if you don't plug anything into the pin, the Arduino thinks that 5V means the device has reached the maximum distance. But if you plug in 4.8V input to that pin, the Arduino will take 4.8V as maximum distance read. Notice that this must be greater than 0V and lower than 5V. My suggestion is that unless you really need the functionality for this pin, don't plug anything into it, just in case some kind of shortage may fry the chip. So the IO ref or IO-REF pin is the IO reference for the board. For an Uno or Mega, it will spit out 5V, and for Do, it will output a 3.3V. It's just an output to tell you the IO voltage. This pin does not have any other functionality other than that. Now lastly, the reset pin. It's the same as the button in the middle. It will restart whatever program that you already have in Arduino from the beginning. So that's all for the introduction to the pin functionality, and I hope you found something helpful in this video. So next time we'll be talking about how to control an LED with digital pins. And thanks for watching, and I'll catch you guys later.